Okay, guys, we are to start. We are to pick up from where we stop in our last section. We were looking at chemistry, paper 4, February, March 2024. In our last session, we looked at question 1. So today, let's see how we can answer question 2. Okay, so question 2, here we go. Okay, so the question. The elements in group 7 of the periodic table are known as the halogens. Halogens can form halide ions. Okay, now identify the halogen with the lowest density at room temperature and pressure. Okay, so generally you want to remind yourself of what density is. Density, you know that density is what? Mass over volume. Okay, that's density. And you know from your elementary physics that mass is the same thing as the quantity of matter. In other words, the amount of particle in a given volume. That's what density is, amount of particle. How many particles are in a given volume? So the more the particle in that same volume, the higher the density. You can see from the relation density, mass. So density is directly proportional to mass. The more the mass, the more the density. So going back to our question, generally, let's go to the periodic table and see what the halogens are. Okay, so halogens are in group 7, so this is the area we are looking at. So you can tell that as you go down the group, the particles increases, the mass increases as it were. So you can tell that as you go down the group, in fact, generally in the periodic table, as you go down the group, they get more dense. The density increases as it were. So density increases generally in the periodic table as you go down the group. So the question or the specific halogen we are looking for is this guy, fluorine is less dense. Now you know generally that in the periodic table, or specifically group 7 elements, as you go down, they get less reactive. Reactivity decreases as you go down the group. That's just for the halogens. Okay, so let's see if we're able to answer the question now. Question 2 with those few information. So question 2, here we are. Okay, so get back to our question. Yeah, question 2. So identify the halogen with the lowest density. So you could tell from what we just explained that is none other than fluorine. Fluorine is the one with the lowest density. Okay, so we make progress. State the appearance of bromine at room temperature. In other words, when you see bromine at room temperature, how will it look like? Tell us everything is going to look like. Now you know that bromine is a red brown liquid. Okay, red brown liquid. Okay, so bromine is a red brown liquid at room temperature. So it's a liquid, and in other words, you are telling us the state of matter and the color that you are going to see. Remember, the elements in the periodic table, they are largely solid at room temperature. 90% of the elements in the periodic table are solid at room temperature. Okay, so a few are gases at room temperature. Only 2 elements are liquid at room temperature. One non-metal, which is bromine that we've talked about, and mercury, which is a metal. It's the only metal that is liquid at room temperature. Every other metal is solid, whereas mercury is the only metal that is liquid at room temperature, and bromine is the only non-metal that is liquid at room temperature. I hope that is taken. So we make progress now to the next question. Now use the periodic table to give the symbol of the halogen with the highest atomic number. Okay, so you have to pay attention to instruction. You are asked to use the periodic table. So we go back to the periodic table again. Yes, so you could tell is this guy. Okay, so I want to rotate this. So this is the guy, tennessine. Tennessine is the guy that is lowest. So it's the last member of the group, so it should be the one with the highest. You can say it's 117, the proton number, atomic number. Okay, so tennessine is the guy we are looking for. So here we are. We need to rotate this again to get started. All right, so what we are looking for, please remember you are told to give the symbol, not the name. Okay, so you remember the rule for writing chemical symbol. The first letter has to be in uppercase, and if there is any other letter at all, that other letter has to be in lower case. If you write it that way, then you know you are writing chemistry. If you have written T, capital S, then you know you are speaking another language, not chemistry. Now, the next question, deduce the number of occupied electron shells in an atom of these elements. Remember, we could use the atomic structure to describe the periodic table. The atomic structure tells us the number that the periodic table is arranged in increasing order of proton number or atomic number. Okay, then the number of electrons in your last shell will tell the group that an atom belongs, while the number of occupied shell will tell the period. The number of occupied shell will tell the period. Okay, so going by what we have here, we can tell that this is okay. So modern periodic table, you know, is made of 7 periods. Modern periodic table is made of 7 periods. So this is period 1, period 2, period 3, period 4, period 5, period 6, and period 7. So for the fact that this guy is in period 7, it means it has 7 occupied shells. Okay, so 7 occupied shells where we can fill electrons into. So tennessine belongs to period 7. So the number of occupied shell for tennessine is none other but 7. Okay, so it's period 7. The question says deduce the number of occupied electron shells. So you can tell from the period it belongs. Okay, so the period atom belong tells the number of occupied electron shells. All right, we make progress. Now, bromine molecules have covalent bonding. That's correct. Now, state what is meant by the term covalent bond. Okay, you know generally that covalent bond is as a result of sharing of electrons. So how would you define it? It's usually a force of attraction between something and something. So we say covalent bond. Covalent bond is the force of attraction. A bond is usually a force of attraction between a pair of shared electrons. I'll demonstrate shortly what this means. Between a pair of shared electrons between two atoms, and their nuclei. Okay, so let me demonstrate shortly, perhaps using hydrogen atom, what we are referring to. Okay, so here we go. Now let's assume that you have a hydrogen atom. You know, hydrogen is made up of just one electron. Okay, so for the first shell, it has only one shell. That's why it's in period 1. It has only one occupied shell. So but the atom is not stable. So for it to be stable, it needs another hydrogen atom. So we have another hydrogen atom this way, and so the first hydrogen atom comes with its electron. Let's use another symbol to represent another the electron from the other hydrogen atom. Let's use a dot, and so we say this is the dot and cross diagram. Okay, so this is electrons, a pair of electrons that are shared. Between two atoms, between hydrogen, this hydrogen atom and this hydrogen atom. So we say hydrogen atom A and atom B. Okay, contribute your electron, bring your electron, I bring mine, so that we can be satisfied. You know, the first shell takes maximum of 2 electrons. So as they are paired together, now they can now say both atoms are okay with the 2 electrons being shared together. Now there is an attraction, because these guys, the electrons, are negatively charged, and here in the nucleus of the atom, we have a proton. The particle, the charged particles in the nucleus of every atom is the proton. So the proton here is positive, the proton here is positive. So there is a force of attraction this way, holding these guys, the shared electron and the nucleus. Okay, force of attraction between the shared electron and the nucleus. So that's the bond, that's the covalent bond. Okay, so that's why we could define it. Look at the definition again. Force of attraction between a pair of electrons. Okay, this is the pair of electrons that is shared between two atoms. And their nuclei. So force of attraction coming from the shared electron and the nuclei. Okay, so I hope that helped to explain that definition. Now we make progress to the next question. Name one halide ion which bromine molecule can displace. You know, I told you that the halogens get less reactive as you go down the group. So the most reactive halogen is fluorine. Fluorine, number 1, followed by chlorine, bromine, iodine, astatine, and tennessine as it were. Now, so anyone that is lower in the periodic table, lower in the group to bromine, will be less reactive than bromine. So bromine, being more reactive, will come and say, guy, get away from where you are sitting, as it were, and I'll take your place because I'm your older brother. Okay, so we are going to list them out, but you just have to pick one. Okay, so you could say Let me see the question again. What's it saying? Name one halide ion. So you want to be specific. You are not going to write iodine, but you are going to write iodide ion. Okay? The iodide, you could write iodide ion, or astatide, or tenside. Okay? Or tenside ion. Okay, so any one of these ones you pick, iodide ion, astatide ion, or the tenside ion. Bromine will displace any of these guys. Okay, so just pick one and you get your answer, you go away. Now explain why bromine can displace. We have mentioned that. Please always mention, you know you are comparing, so you want to tell us. Please use proper English to tell us. Don't tell us that bromine is more reactive. Yes, bromine is more reactive, but then are you saying it's more? Let's say just write bromine is more reactive. Please note that this is not a complete statement because you have not done a proper comparison. Bromine is more reactive, yes. More reactive than what? Are you comparing it with fluorine? If you are comparing it with fluorine and you say bromine is more reactive, that's incorrect, you know. So you want to be specific. You want to do proper comparison, okay, so that you can earn your mark. If you've written this bromine is more reactive, please know that you won't get any mark because you've not said anything, okay? You've not done a proper comparison. So you are telling us bromine is more reactive than whichever one you have chosen. Perhaps let's say you've picked iodine in the first instance, so you say it's more reactive than iodine. Okay, that's fine. I hope that explanation helps. Now the E, name a halide compound which can be used to detect the presence of water. Now, you know, there are two compounds that can be used to detect the presence of water, and that's both of them have to be anhydrous, not the hydrated salts, but the anhydrous salts. Okay, so we are talking about the anhydrous salts of cobalt. Okay, anhydrous cobalt. This way, anhydrous cobalt 2, anhydrous cobalt 2 chloride. Okay, so you can see it's 2 marks. So the word anhydrous will give you 1 mark, cobalt 2 chloride will give you a second mark. So if you have omitted the word anhydrous, please note that you have lost 1 mark. Now the second compound that can be used to detect the presence of water is anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate, we go from white to blue, while anhydrous cobalt 2 chloride, we go from blue to pink. Please don't get it twisted. Always remember the color, the change in color. This specific one, anhydrous cobalt 2, we go from blue to pink, while anhydrous copper 2 sulfate, we go from white to blue. Okay, so don't confuse yourself with the blues that are there. Just get it straight. Okay, now we make progress now to F. Calcium chloride is an ionic compound. Complete the dot and cross diagram in figure 2.1 for the ions in calcium chloride. Give the charges on each of the ions. Okay, so you know, in this instance you need to draw a complete diagram. So we are looking, because they are not looking for just the last shell. So in fact the diagram have been drawn for you. So all you need to do is to complete the diagram. Now you know chlorine is element 17, so it has 17 electrons. Now it has to gain 1 electron to become the chloride ion. So you are drawing a shell, the last shell. Okay, forgive my imperfection in drawing. Now this electron has to be represented with a dot, so please use dots, okay, use dots. This way we are pairing the electron for easy counting. Okay, so that's the 7th electron. Now it's going to gain electron from the calcium atom. Okay, so calcium atom is gaining electron, and the electron for calcium is represented with a cross, so you want to represent that. Okay, so calcium has 20 electron. However, the 2 electrons in the last shell will be lost. One of them will be given to this chloride ion that I have drawn, then the other will be given to the last chloride ion. Okay, so you are left with just the 3rd shell. Okay, and all 3rd shell we have 8 electron complete, and you have to use cross. You have to use cross because the instruction says the calcium ion or calcium atom here is using cross. The electrons are crosses. Okay, so we move to this guy and we do the same just like we did for the first chloride ion. Okay, so we are using dots again. Here, yeah, I hope you get it. Please do. Okay, so you have this, we have cross. Okay, so the last shell that we are asked to complete is complete as it were right now. Now we will need to put the charge. We need to put the charge where it is. Okay, so for the chloride ion, it has gained 1 more electron, so you put that minus sign there. Okay, okay, for clarity you can just put 1. That means it has 1 more electron than proton. Remember, nothing has happened to the nucleus, so it still has 17 electron, but the number, 17 proton, but the number of electron has increased to 18. So we have 18 electron and 17 proton, and that's why it's giving you -1. -1 is simply telling you that it has 1 more electron than proton. Okay, so we do the same thing for this guy. This guy has lost 2 of his outer shell electron, so it becomes +2. What that simply means is that it has 2 more proton than electron. The number of proton in the nucleus here remains 20, but it has lost 2 electron, so here we are left with 18 electron. 18 electron. So we do the same thing for this guy, and we put the minus sign there. Okay, so you have minus sign. You can decide to put 1 there. All right, that's fine. We appreciate that. We can make more progress now to the next question. We look at this. You have the G aqueous lead-2 ions are added to aqueous chloride ions. A white precipitate of insoluble lead-2 chloride PbCl2 is formed. Name a lead-2 compound which can be used in this reaction. Okay, so this is simple enough. You know, this is a precipitation reaction, and you know generally that in a precipitation reaction you are missing 2 solutions, 2 soluble salts, 2 soluble salts to get 1 insoluble salt and 1 soluble salt. Okay, that's a precipitation reaction. So how can you get the 2 solution, 2 soluble salts, 2 soluble salts? So you want to remind yourself, what do you know about solubility of salts? Please note, remember, that all nitrates, right? All nitrates, okay? All nitrates are soluble. Anything that is made up of nitrates are soluble, okay? Anything nitrate are soluble. So if you are given these kind of questions, always think in lines of nitrates. So any lead compound that is going to be soluble, that is going to be a solution, has to be a lead 2 nitrate, okay? So here you are simply saying you have lead 2, okay, lead 2. So you are thinking in terms of lead 2 nitrates. Alright, lead 2 nitrates it is. Okay, so we make progress now to the next question. Write the ionic equation for this reaction, include state symbols. Okay, so this is simple enough. Let's go back to the question. So each time you are given ionic equation to write, please don't panic. Don't panic, especially when you are given ionic equation that has to do with a precipitation reaction. Okay, if you are given ionic equation that has to do with a precipitation reaction, the rule is simple. This is what you do. Just think, what is the precipitate? You know that precipitate or solid don't form ion. From your common knowledge of ionic compound, you know that solid ionic compound cannot form ion because the force of attraction holding the oppositely charged ion is strong, so they don't exist as ion. Okay, so solid don't exist as ion. Okay, so because they don't exist as ion, just go and write that solid first. I'm saying use this rule each time you are asked to write ionic equation for precipitation reaction. Okay, so just start with the product. What's your product? You are told that an insoluble lead 2 chloride is formed. So you have your lead 2 chloride being formed. Okay, lead 2 chloride, and since it's insoluble, it's going to be the precipitate. So you put your symbol there, S. Now, so think, these precipitate, what are the ions that can form this precipitate or that can form these insoluble salts? You can tell that it's made up of a lead and a chloride. Okay, so and you know, when we write formula for compound, in fact they've helped you in that they've given you the formula of the compound already. So remember, when we write formula for compound, what do? The charges are usually swapped among the particles that are involved. So if lead has given 2 to the chloride ion or to chlorine, then you can tell that you are having a lead 2. That's plus. Okay, and lead, for it to exist as ion, it means is aqueous. Okay, it dissolves in water. Okay, so what you have left is the chloride ion. Generally, you know, chloride ion are negatively charged that way. So for it to exist as ion, it means it's dissolved in water, and you have that. Okay, so you have this, then you can balance the equation by putting 2 here to say that we have 2 chloride ion. That way life becomes so easy. So ionic equation, have no panic. Now your ability to be able to write the products correctly, 1 mark. Your ability to be able to write the reactant correctly the way it is, 1 mark. Your ability to include the state symbols, because they said include state symbols, 1 mark. Okay, so that's fantastic, well done. Now the next question, name one other insoluble chloride. So generally you know that all chlorides are soluble, just like we have here. Okay, so all, we want to write that all chloride, anything that is made up of chloride, at least all chlorides are soluble. Okay, All chloride are soluble. In other words, all chloride will dissolve in water. There are exceptions, okay? Except chlorides of lead, that we have mentioned here, and chloride of silver. Okay, chloride of silver. So lead 2 chloride, silver chloride are the insoluble chlorides. Okay, so what they are asking for, name one other insoluble chloride. They are looking for silver chloride. Okay, so you are writing silver chloride. Okay, silver chloride it is, and that way you get your full marks. So this has been fantastic. Well done for your participation. We appreciate having you here. Now please do not forget to subscribe to our channels. It might mean nothing to you, but it means a lot to us. Please do subscribe to our channels. All right, so see you in our next session when we'll be answering the question 3. Thank you so much. Bye for now.